Thank you all. Welcome. This is kind of our second time doing an event like this during GTC, really bringing together the folks who are deeply interested in what the future of AI at the edge is going to mean. And I am privileged to be joined by a really wonderful panel of experts from across the industry to really sort of share the insights that they have. And we'll have time for some questions at the end. But I think this is a great opportunity to just sort of establish a baseline, get the foundations, and then talk about where things are going from here. So let me go ahead and let the panel introduce themselves. But I've got some questions. My name is Dormain Drewitz. I lead marketing and education at ZEDEDA, which I think many of you probably know at this point, but we build an edge computing platform. We made an announcement last week about sort of our expanded support around NVIDIA, so timing really well with this week's event. But I am here also as the student. So I am excited to learn from this panel, and I hope you are excited about that as well. So why don't we start over here with Bill?
Yeah, absolutely. Mic working okay? Bill Conrades. I'm with the Heads Foundry division. Been with the company for 19 years, and our focus within Foundry is on edge AI, embedded systems, and appliances. So that's going to be my perspective today. But we also integrate systems at rack scale for enterprises. So it's a pleasure to be here, and we see ZEDEDA as a critical partner for what we're doing in edge. Yeah.
Awesome. Amit.
Yeah, hope the mic's working well. Amit Ronen, I'm from Wind River. For those of you who don't know, Wind River been around for about 40 years, and what we do is we supply software, mainly real-time operating systems, and some middleware for what we call mission-critical systems. And the slogan we like to use is when it can't fail, you come to Wind River. So you will find us probably, if anybody flew in here, our software is in most of the airplanes, missile systems. We are on Mars with the Mars rover, telecommunication, industrial, medical devices, all of those devices that if they fail, really bad things happen. So that's Wind River. We are part of Active now, which is in the automotive industry. Myself, I'm the Chief Customer Officer. You beat me a little bit here. I'm almost 18 years at Wind River, so tiny bit ahead of me. Yeah, thank you. And excited to be here. Local to the Bay Area here, so great to be in the panel. Thank you.
Thank you. Dan.
Hi, so I'm Daniel Situnayake. I'm the Director of Machine Learning at Edge Impulse. And so we're basically a developer tools company. We've created these systems that make it a lot easier to train and deploy machine learning models to edge devices. So that could be anything from a microcontroller up to MPUs, NPUs, GPUs, anything that's basically processing sensor data at the edge. So yeah, we're really excited about not just kind of the technology behind edge AI, but the usability and how do we get this in the hands of as many developers as possible. We have a pretty big community, a couple of 100,000 developers that use our platform. Last week we announced that we're in the process of being acquired by Qualcomm. So that's our big exciting news recently. It's nice to be able to say that publicly.
Wonderful. And Padraig.
All right. Well, first of all, congrats to Dan and the team.
Thank you very much.
Yeah, nice job. So yeah, my name is Padraig Stapleton. I'm the head of product and engineering at ZEDEDA. As Dormain said, we're very much focused on how do we enable deployment of applications and solutions at the edge. And our technology is all about, I think, taking the friction out of that experience for our users, both through the EVOS that we deploy on the edge nodes, as well as the orchestration solution that we run on the cloud solution. I think, our vision is how do we enable cloud services at the edge, and that's very much what we're trying to do. Is trying to make the experience that people have had at the cloud, bring that to the edge, so that they can do all the same things they've done in the cloud, be that running their applications, running their ML type of applications, solutions, etc. Be able to do that at the edge, do that securely, and do that at scale. So that's what we're working on here at ZEDEDA.
Perfect. One of the first things, before we get into the AI side of things, I know that's the hot topic, but I think it's really important to sort of establish what do we mean by edge? This I have learned in the sort of 6 months since I joined ZEDEDA is like it can be a squishy word. It can mean different things to different people. So we'll work back the other way, but just some of the defining characteristics that folks should be thinking about, like what do we mean by edge versus the whole spectrum of where compute runs.
Well, I think edge is pretty much everything that's not running in a data center today. I mean, it's everything from, you said, like airplanes, fighter jets, through like devices in a shop floor, to devices in a retail center, to devices at oil and gas platforms. So it really covers a wide gamut of use cases. So I think the way I think about it, just anything that's not running in a big data center is
Okay.
pretty much the edge these
Yeah.
days.
Good contrast. Dan, would you add to that?
Yeah, I mean, I guess like Mars is the most extreme example of the edge that I've heard today.
That's very far edge.
But I think sort of this idea that the edge is where the data is being produced. The cloud is kind of where it goes eventually and where it gets computed and crunched and analyzed or stored away. But to me, the edge is anywhere that data is originating from, and probably in a higher frequency than you want to deal with in the back end.
Yeah. And I think that's going to come up in some of our later questions. But Amit, what would you add?
Yeah, I will add on what you guys said, which is very accurate, obviously, is the way we see the edge, we see it as a continuum. And I think it's going to be very relevant to the discussion when we talk about AI, because that's the same thing. There is the very far edge, it's maybe start with the sensors, and that goes eventually all the way until it gets to the cloud. So this is a continuum between what we call edge to cloud. And we look, it's not just one single class of devices. There are multiple classes of devices between the very, very far edge, all the gateways, the edge servers, the near edge, and then you get into the database, the data center, sorry. And I think when you also start implementing AI, we'll talk about it, that has a role to play, each of those classes of devices along the way.
So I'm hearing data, I'm hearing diversity.
Yeah.
My initials are D and D, so I'm all about this alliteration that's building up here. Not to put the pressure on Bill, but
No worries.
what would you add? It doesn't have to start with the D, but that is the letter of the day if we're playing Sesame Street.
Yep.
What would you add to kind of just thoughts about what makes the edge the edge?
Yeah, I think our story is very similar to yours. We
Mhm.
delineate the different types of edge
Oh.
deployments.
Yeah.
Far edge, these are devices where sometimes there's not humans around to work on the systems or to perform upgrades. They're out in rugged environments, extreme temperatures. They're closest to the sensors generating that data. And then you have the near edge. It's interesting. Our EVP was at a summit with CIOs and CTOs, and he asked a question: who has edge deployments out in the audience? Only 2 people raised their hand. He asked it a different way: who has distributed infrastructure? Half of the room raised their hand. So when you think of distributed infrastructure, think of retail locations, factories with data center closets, but it's not the core data center, right? And then beyond that is your cloud computing. So that's how we look at it and differentiate between.
Okay, so I think that establishes some important foundational truths on which we can then dig into the AI question around, what is really AI at the edge? What makes that different from, say, AI in the cloud, right? Can't remember, someone was mentioning like the whole server racks that are, in some of the booths here at the show. What's different about AI at the edge? I'll start with you, Dan, just to mix it up.
Yeah, let me think. I mean, it's this sort of idea that like on the whole spectrum of like what do you want to do with AI? I think quite often you're trying to do something very different with AI on the edge than you would be doing in the server. And like in the history of like applying AI to data that's flowing in networks, sort of starting with like big data kind of stuff that was popular, when I was getting started. The idea is that you're trying to crunch numbers to figure out some useful information about like how your business is doing or how some infrastructure is performing or something like that, or predict something about how your customers are behaving. To me, I see AI at the edge as a lot more sort of tactical. Like things are happening, events are occurring, sensor data is being generated. There's things going on in the real world that are important. And AI at the edge is all about dealing with that and trying to understand what's happening and turn that into information that is relevant inside a computer system that could be subsequently used for analysis. So an example there would be you don't want to be necessarily ingesting huge amounts of raw time series sensor data and writing it all into your database. For a bunch of reasons, it's sort of not a good decision usually from an efficiency point of view. So if you can try and figure out what does this stuff mean as close to the edge as possible, and then send information about what it means back to the database, then you can much more easily work with it in a real system.
So is it fair, like what you're talking about, it almost sounds like there's a lot of the inference side of things that has to happen in real time. This maybe is a little bit of a leading question, but as we think about the challenges of AI at the edge, and how that is part of what makes AI at the edge different. Bill, let's hear your thoughts on this.
Yeah, I'll tag on to what you're saying. It's real-time inference in many cases where you have to make a quick decision. You can't wait for the latency of the core data center or the cloud to make that decision. And why is it real time? Because milliseconds may matter to saving a life. It may matter to the quality of a product. And the deployment of the hardware is very different. Sometimes it needs to be ruggedized. Sometimes it needs to be portable. Generally low power. Power is not cheap. It's not easy to access in far edge locations. So a lot of core differences there than your standard rack mount computers.
Yeah, no, and I think about like, hey, we're going to liquid cool our GPUs in the data center, and it's like that doesn't sound like anything that you're going to be doing at the edge. You brought up real time. Amit, this sounds like something you're going to have some thoughts on.
No, absolutely. And I will add on top of what you just said, when there's a term when we work with our aerospace and defense customer, they have this term called SWAP, right? Stands for space, weight, and power. And this is classic for the edge, right? Because when you look at the edge, it's usually very limited in resources. Sometimes space is an issue. Power is definitely an issue. And when you deal with the edge, you don't have unlimited power. Many times it's battery powered. And compute, memory, all the resources are very constrained in the edge. So swap, is a big issue when you deal with the edge, especially when you're going to talk about AI that is resource intensive. And then the other thing I will add, the edge is very diversified. If you look on devices on the edge, the architecture, whether it's ARM or, different architecture, even inside ARM, it's a lot of custom boards. So the diversity of the architecture at the edge is very different than what you'll find in the cloud, which everything is roughly homogeneous, right? One or two operating systems that people are using there. The silicon architecture is fairly same. You don't find it in the edge. In the edge, there's a huge diversity that creates a big challenge on how you deploy different things from AI or not AI, but just deploy stuff at the edge makes it significantly more complicated.
Yeah, and I know a lot of those challenges for you, Padraig, resonate in terms of, these are the challenges at the edge. How do you see those showing up as folks look to deploy AI at the edge?
Yeah, I think the other big thing is around, we think of the word constraint, is actual data itself.
Yeah.
Actually getting access to data at the edge that you can use either to train the model or inference or to optimize is always a challenge. I mean, I know there's a lot of techniques out there, either trying to use synthetic data or digital twins, but I think there are technologies that have a ways to go before they can really, I think, replicate the quality of having access to real data. So I think the lack of data sets readily available for application in different use cases, be that retail, oil and gas, you name it, I think is a challenge for all of us at the edge.
Yeah, I want to add one more thing. I think you touched on it. Connectivity to the edge is not given, and that's complicated. Not always reliable, and you can't always rely that you're always going to have connectivity. I do want to highlight one thing, and simply because I had this discussion with a journalist last week, that things came up in this IoT of things, right? The IoT stuff, and people say, "Hey, that was a hype, and now we're in a different hype called AI." And I said, "Look, it was not a hype. 10, 15 years ago, lots of devices that we dealt with were not connected. And through IoT, maybe we didn't see the commercial deployment yet or the monetization of IoT the way people expected to see. But it created a huge revolution that now every device is connected. There are very, very few devices that are really not connected. And actually, that enable AI at the edge. Without that, there's no AI in the edge, right? So, again, just an anecdote. I think connectivity is a big issue at the edge.
And you're that's a great point. And you're setting the table. We've kind of established like a lot of challenges. It's almost like, why bother, right? This sounds
Yeah.
hard. Like, why go through it? What's the opportunity if you can overcome these challenges at the edge? Amit, let's start with you.
Yeah, and I think you start with that. Uh, Look, most of the data actually is going to be generated at the edge, and it is generated at the edge because this is where the sensors are. So for all those devices that are out there in the field, the data is there. Now the question is, what do you do with the data? And without AI at the edge, it's going to be very complicated. You mentioned, hey, how do you decide how much data you transfer back? You can't transfer all the data. Some of those devices will generate terabyte of data a day. That's number one. Number two, decision making, right? A lot of those devices, you need to make decisions and response time really quick. It has to be at the edge. You can't do this turn, over back and to the cloud and back. So, you can't transfer all the data. You need to make decision at real time. The data is generated at the edge. So there's a lot of reasons why you want to do AI at the edge. Actually, it makes a ton of sense to do AI at the edge. So yeah, I think this is a huge opportunity.
Yeah. Bill, when we had our prep call, you had
Yeah.
some interesting stories about what you've seen with customers that have driven them and are the motivation for them to actually figure out AI at the edge. Maybe you can
Yeah.
share a little bit of that.
Yeah, absolutely. So I'll tell a story. We have a client that dealt with the loss of life about a year ago, and they wanted to increase quality in an application of autonomous machinery driving that is used to repair infrastructure. And so during these repairs, loss of vision happens all the time, kicks up dust, low visibility environment. And so they decided we're going to create an autonomous driving application. They outsourced that work to an ISV. They needed a hardware partner to deploy the platform on top of these rugged machines that create a lot of vibration. And so by doing that, they brought in sensor data from vision. It's a computer vision application. They're using LiDAR. They're using connectivity. They're evaluating a platform for edge management in these devices. But through that, their goal is to prevent the loss of life so that these machines can drive and stop and move more accurately than humans can. And I think that's one of the benefits. You're augmenting staff, you're decreasing cost, you're improving reliability, you're improving quality, no matter what industry you're in once you operationalize it.
Padraig, I know some of these kind of use cases in terms of, what people are building at the edge with AI. Like, what's the types of things that are getting them over the hump of let's figure out how to overcome these challenges.
Yeah, I think it's at the end of the day, it's all value and a use case, right? I think everywhere we go, people are deploying it because they have a problem they're trying to solve, and in some cases, the problem could be that they are deploying in very remote areas and they have no connectivity. So, in order for them to be able to evaluate the data that's coming out of their systems, be that in oil and gas or some other type of industry, they have to process the data locally. They have to do the AI. They have to figure out the result and then make a decision. And in some cases, what this is doing is it's allowing them to actually evaluate next steps, as opposed to historically they'd have had to take the data, send it back, wait, and then get an answer. Now they can process it, decide next steps, what to do with maybe it's a well, maybe it's some other asset, etc. So it really increases the efficiency in a number of businesses. And I think it's that lack of connectivity is why they're trying to do more at the edge, and also it's security. I think we're all in a world now where people are extremely sensitive to cybersecurity issues, and in a lot of cases, a lot of companies, the data that they're extracting at the edge is their IP, and they're very sensitive about sharing that over internet or any other type of transmission. So they want to process as much as that locally, run the AI, make the decision, and then move on.
I'm hearing safety. I'm hearing speed. I'm hearing security. Now we're on the letter S, in case anyone is following along the alphabet. Uh, Dan, you've got some interesting perspective working with the developer community, right? Where there's always tremendous innovation, but what are you seeing in terms of the like, ooh, these are the things that really pull the business case forward?
Yeah, I mean, I think it's such a wide range of diverse things that people are building and doing, but I really love this acronym um, that is BLERP, BLERP. It stands for bandwidth, latency, economics, reliability, and privacy. And I think that does a really good job of capturing the breadth of um, reasons why, you don't need a tick in every column. Maybe you even need a tick in one column, but it's a compelling enough one to justify this extra complexity of doing inference at the edge. There's so many different reasons why this might be important in a given application, and it all kind of adds value. There are some use cases where you just have to do things at the edge, and you wouldn't be able to do it at all otherwise. And a lot of those tend to be safety critical. So, imagine you've got some system that's controlling some kind of safety mechanism. You can't have that stop working when the internet connection goes down. So there are some things that you literally couldn't do before we had this type of technology, and other things where there's just enough of a value added by moving things to the edge that it just starts to make sense.
Yeah. Let's go talk a little bit about the history of AI at the edge, because I think this is something across the industry. There's been so much hype around AI in the last few years, since ChatGPT and everything. But AI is not actually new. I was just sitting down with an executive last week who had I got my PhD in AI like 25 years ago, and so maybe tell us a little bit about how long has this actually been around? How widespread is doing some forms of AI at the edge? What does that look like? And then, we'll get into kind of now what's changed, but just give us I was a history major. I want the backstory here. So Dan, let's start with you.
Cool. Well, I mean, I got started with this stuff about 7 years ago or something, working at Google on the TensorFlow Lite team. So we were building software for running models on cell phones, which are at the edge. And no one really thinks about this, but even back then, for quite some time, you've been able to get these voice assistants that were, you say the keyword and it wakes up and you give it a command and that runs on your phone. And the wake word part ran on a DSP on your phone. And so I've spent the last 7 years or whatever trying to persuade people that edge AI is a thing and that you can run models on, low power hardware in your pocket, for example, or, in some kind of gadget. And the whole time, everyone in the entire world has been walking around with an edge AI, very mature edge AI application running on their phone. So this stuff's been around and been quite mature a lot longer than it gets credit for. I think the challenge is that back then it was only really the Googles and Apples of the world that could pull that stuff off. The complexity of the tool chain of development, going from training a model, optimizing it to run on this very specific hardware, testing it, managing it across a fleet of devices, was just not stuff that had been figured out. And so the story of edge AI for me, I think, is the story of all these bits getting figured out to bring it within reach of pretty much any developer or any company that's trying to solve a problem.
Okay, I really want to ask some follow-up questions there, but I want to hear from some other folks. Amit, just in terms of the history and kind of how long you've seen AI at the edge and how widespread do you see it?
Yeah, look, I'm not an historian here, so I'll take it with a grain of salt. So look, from our perspective, we deal with real commercial implementations, and obviously there was a barrier to take things to the edge. You needed to see a commercial use case where people really want to do that, and you needed to have a lot of things connected because, look, yes, there's a huge case to be, we are debating here a case for AI at the edge, but honestly, AI at the edge doesn't exist without the cloud, right? It all starts in the cloud, and until the AI in the cloud reach a certain level of maturity, I think it's going to be, it was very difficult really to push it to the edge, and we can discuss, the challenges and how do you do that. But it has to reach some level of maturity. People say, okay, I understand, okay, I have all the models that are being trained and so on. Now, how can I get it to the edge? So really, in commercial perspective, similar to what you said, I would say probably in the last 5 to 7 years, we started to see, people talking about it. I don't want to say that a lot of implementation taking place, but lately it's accelerating in a logarithmic, scale from that perspective. That's what we see from our perspective. But as they say, we all stand on the shoulder of giants, and you need those giants, the Googles, and to have a sufficient investment to reach a critical point until everybody else can adopt it and really use it on a commercial level.
Yeah. And Borg, there's some of the industries that I know you work closely with that are also pretty mature in some of their AI implementations at the edge.
Yeah, I think some of them are even like the telco space, which I spent a lot of time in the last few jobs. That's an industry that because they had a wealth of data, actually, they were doing a lot of AI. Some of it back in the core, but some of it kind of distributed out at the edge of the network. So that was an industry, and again, they had the resources, right? It's a very a lot of resources to be able to do it. So I think for them, it's not new. But I think outside of that, it was mostly in kind of islands. There was certain, I think, leaders within verticals that were actually, I think, pushing the envelope on AI. And I think what's changing now, I think, is with the advent and the price of devices coming down and the power going up. I think it's really kind of democratized people's ability to run and access to these types of tools. I think it's a combination of that plus the software tooling that's become available in the last 2 or 3 years that's really starting to let it flow out to the edge. And it doesn't require as big an investment in people and capital as it did 5 to 10 years ago to get that up and running today.
Yeah, you actually brought a good point, if I may piggyback on that. And you said data, and that's actually the most important part, right? Data is the currency for AI. And especially on the edge, a lot of people didn't have the data because, as we discussed, not everything was connected in many years before and so on. So you just, you talk to people, you didn't have the data. As if you Google, you worked on phones or Apple, yes, you had the data, but you were in a unique position. If you look on most edge devices, just didn't have the data,
Yeah.
to do all that.
And you're getting to the next question I have, which is kind of like, okay, what's changed recently?
Yeah.
Like what's possible now that wasn't possible before? Before you talked about kind of the changes at the device level in terms of more power, more efficiency. Bill, what do you want to add on to this in terms of
Yeah.
both kind of where have you seen things in the past and how is this sort of like rounding a corner into the future?
Yeah, so I'll start with computer vision. I think we've seen applications over the past decade that started out not as your AI models today, but more of a traditional machine learning sense. And they required a GPU for acceleration to be added to a traditional x86 server. And then right around that time period, Jetson was released, Movidius was released, decreasing the cost to accelerate at the edge. And that was really interesting to us. When we first started using Xavier Jetson, we were able to run a single model and inference off of a single stream from a video camera. Then AGX Orin came out. We could run two models. If you saw the demo over there, two models were being run, multiple sensor streams at the same time. And the cost footprint and the power is decreasing on this ARM architecture, which is making it easier to deploy and is expanding the number of applications you can use it on versus putting a GPU in an x86 server, the amount of power and heat that puts off in a traditional rack mount enclosure or some large form factor. It's totally different now. It's easier to deploy. It's lightweight.
No. Dan, how about you? Because you kind of set the stage as sort of where we are is like, are we there yet? That was what I really want to know.
Yeah, I mean, things have just been changing so much over the brief course of time that this whole thing has existed. And I mean, I remember thinking what it would be like if we could do vision on microcontrollers and then suddenly we could do, actually like run these convolutional networks on a microcontroller in like a not quite real time, but real time enough to be useful. Fast forward, 5 years or so, we've got like generative AI became a big thing, and now we have edge hardware. I wouldn't say low power particularly, but relatively low power edge hardware that's running large language models and vision language models on the edge, which completely changes the way that you sort of the developer life cycle of working with these things and how much data you need and that type of stuff. And it's almost this like uncharted territory, and it's all the whole way it's sort of unlocked by these incremental improvements in hardware, and then the same with the algorithms getting more efficient and people getting better at training with a smaller model. So it's really just this ratcheting of technology, and there was a point before any of this was really possible, and then it suddenly became possible, and now it's just really blooming.
Yeah. Padraig, what do you want to add in terms of what do you see that's changing, that's sort of causing this sort of shift in the market?
I think it's a few things really. One, it's the tools, right? It's the large language and it's the small language models which are coming as well. I mean, I know it's the large language models get all the press and all the hype, but I think it's the derivative of those that is actually going to have the biggest impact, especially at the edge, because those small models, when they're trained for a specific use case, can be extremely powerful. And I think I don't think we know yet all the list of use cases that they'll enable. But I'm pretty confident that we'll be sitting here 2 years from now and we'll be saying, I never saw that coming, with respect to using the small language models at the edge. So I think there's going to be a big explosion in just adopting of those and pushing them out to the edge and figuring out new and innovative ways of deploying it.
And I've got a question here. I want to come back about talking about scale for a minute, because when you talk about the edge, we talked about some of the challenges, safety, security. Those are diversity, data, but scale is another interesting part of the equation, because you're talking about not just scale of what's inside a nice temperature controlled data center somewhere. You're talking about scaling across lots of different locations. It adds a different challenge. What does that mean for how folks need to approach building and deploying AI at the edge? Amit, let's start with you.
Yeah, no, I think it's a huge challenge. And I think as we discussed at the very beginning, right, when we see on this, as I said, this continuum of devices, when you go with the really far edge all the way to the data center, um, the far edge is very distributed, as we said, not homogeneous, and geographic distribution is one challenge, right? And the scale, the numbers are significantly more devices that you need to manage. So you need to create different model, and that's the data transfer from one class to the other until it reaches the cloud. Each has a different role to play, and now you need to orchestrate also not only just the devices and the deployment, but the different models and how you treat the data. So, for example, if the sensors level, right, when the sensor get the data, this is where you need to get the quick reaction. So you process the data really quickly and you generate a quick reaction, but then you need to transfer the data. And again, what data? So you just transfer some of the data to the next class, right? It's maybe like the near edge where you do more processing and you aggregate more data for more devices, right? So that's maybe a slightly different model that you need to deploy. And then it's push it back to the cloud where maybe you do retraining and then you want to push it back to the devices. So the complexity of the orchestration that you have here is significantly higher
Yeah.
than when you deal in a data center. Everything is one place and it's significantly more homogeneous.
Yeah, there's layers to the
Yeah.
onion, if you will. Bill, what do you want to add in terms of what do you see in terms of how scale shows up in challenges,
Yeah.
edge AI deployments?
So you're talking about rolling out a lot of devices at one time, not just containers or virtual machines in a core data center or the cloud. So this is where a head feels that an integrator can really help out, especially when you're deploying to the far edge, getting the device prepped as much as possible before it's deployed out, and then knowing what's in the field. When's your warranty going to expire? What is in that system? So having strong asset management and lifecycle management is key, in addition to where are these going out in the field. You may need professional services to install them. Some of these edge devices are up on light poles, as an example. And then managing the devices in the field through a strong tool set like ZEDEDA for edge orchestration. A lot of clients that may be an uplift, so offering managed services to do that for clients just makes it more seamless. It's still a fragmented market, but the best thing we can do is help that experience go a lot smoother, especially with the scale being upwards of 20,000 units in some use cases. It can be fleets of deployments.
Okay. Yeah, there's a lot of like, how do you simplify all this heterogeneity and the layers of the onion?
Yeah.
That makes a lot of sense. Porg, what do you want to add in terms of, thinking about scale and how does that complexity show up with AI?
I think there's two real aspects to it that we're always thinking about here. One is the security. As you said, when you're deploying these in all these different locations, right? And again, they're all dealing with data or processing data that's IP to that company. You have to ensure that it's done in a manner that's secure. And a manner that these devices, unlike in a data center where they're usually locked and secure, they're basically out in the wild, and you've got to ensure that they cannot be tampered with. If they're stolen, the data cannot be accessed, etc. So we see that as something that's really critical for a lot of our clients going forward. And then I think the other thing is just operational visibility. I mean, they're out there, right? And they're running mission critical applications for people, but that doesn't mean you can't be aware of what's going on in that device 24/7. So that operational ability to actually know what's happening, be able to get alerts and be able to react to it and be able to process it and determine whether it's severe or it's something that's maybe less severe, or if you need to actually take action immediately, I think are some of the challenges that make the edge a lot more difficult to deal with than something sitting in a rack in a data center.
And Dan, from your perspective, right? Developers will often kind of have to work on, hey, this is what I can do, and it worked on my machine. Now, what does this do when you're talking about thousands of nodes? How do you see that play out?
Yeah, I mean, it's a really tough problem that you sort of it's a problem that exists for machine learning and AI generally, but when you're talking about the edge, it gets much worse because, imagine you've got a model that's recommending products on a web server for an e-commerce site. Um, you can kind of check if it's working well or not because you can recommend a product, and if people don't buy it, then your recommender is not working well. And you have that instant feedback because it's all running on the cloud in the server. Um, Now imagine you've trained models and those models are right at the far edge, sitting on devices that don't necessarily even have a way to communicate much back at all, if anything. The model could be completely doing something utterly wrong, and you'd have no feedback mechanism for detecting what's going wrong, figuring out what you could do to improve it. So there's this idea of drift, which is that the world changes, and you train a model on a snapshot of the world, which is your data set, and then over time, the actual conditions of the world are going to change and evolve, and your data set doesn't necessarily represent it. Um, Once you've deployed that model to the edge, that's got this outdated snapshot of the world. It's almost inevitably going to drift at some point. It could be that the world is changing. It could be that your hardware's degrading slightly, or some part of a machine is getting worn down and changing over time, changing your signal that you're looking for. So you really need some way to monitor that and figure out, like, is the distribution of inference results starting to change over time, and then that's a clue to maybe send someone out to have a look at it. Maybe you need to dig into this. Maybe you need to collect some more data. But it's just very challenging. I think monitoring models in production is like in edge AI is kind of a new thing, and that we're trying to figure out best practices for, and it's going to be an evolving, really important topic.
Yeah, I mean, when you've got drift in the data center, that's one thing. You've got different levels of drift across, a fleet of the scale you've been talking about,
Yeah.
right? I mean, the thought that comes to mind is like 1,000 snowflakes, right? That each have to be sort of considered individually and yet managed efficiently. I'm going to skip the next couple of questions because we touched a little bit about data availability on the edge. And just in the interest of time and leaving some time for the audience to ask some questions, just a final kind of closing comment from each of you on sort of looking ahead. What are the key things that need to be overcome for continued acceleration? Amit, you talked about kind of the tipping point that things seem to be at. What are those gaps that need to be filled in the industry? What do you think is going to be really driving things forward? So, Amit, let's just start with you.
Oh, okay, it's a big question. Um, Look, I think at the end of the day, look, what's really going to drive things forward is economics, right? And people need to see economic benefits from deploying AI at the edge. So maybe, people like, it's a good buzzword and so on, but we need to find, first of all, the real use scenarios that really drive economic benefits for people. When you see that, a lot of things automatically fall into place. And today, I think there are good examples, but they're not in mass. And we need to get there where people believe, okay, they can really crystallize those use scenarios for them, that they can say, okay, that can work for me, and they can calculate, the economic benefits for them. I think obviously the tool chains, as we described, I think the hardware, all those things are there. I think the operating system, that running all that, from whenever type of things are there, right? We are there. So in a sense, we are ready for those use scenario. But I still think that, yeah, it's a new technology. And a lot of people don't know that. And you just need to get to this adoption phase like any new technology that people are, hey, I say AI is great, but what does it mean for me and how do I use that?
Yeah.
And we see a lot of customers say, I don't know even where to start when it comes to AI. So look, there are always a lot of fundamentals. We talked about it. You need the data, right? Everybody, hey, you need to sort your data. You need to clean the data. You need to make sure that you have it ready for consumption. That's a big challenge for a lot of people. But I think it's going to take time. People will need to adopt this new technology. I think a lot of the components are already there. If you ask me. Yeah.
Yeah, no, the business case makes sense. I was talking to a head of AI recently, and they were like, "Yeah, if it's something that's going to save you 15 minutes of employee productivity,
Yeah.
like don't waste my time.
Exactly.
It's not worth it." But he had other use cases that were like,
Yeah.
"No, this gives me money. This
Yeah.
brings revenue into my business, so that's where I spend my time." So,
Yeah.
yeah, I think you're spot on. Dan, how about you? What do you see as kind of what are the hurdles we have to overcome for this next leg of growth,
Yeah.
transformation?
I think from a developer perspective, we see so many thousands and thousands of different projects on all sorts of different topics, but the thing that unifies it for me is data. It's so hard to have enough data. Some companies have tons of data and they're like, oh yeah, look, data's not a problem for us. We've been collecting it for years. But then they just have terabytes of unlabeled random values, that essentially are not useful at all. And having that like high quality labeled data that you can use to train models is difficult. And the thing that is really key with edge applications, I think that's a little bit different, is if we're training a general model that works for vision in a general sense. You can scrape images from the internet and you can train a model on millions of pictures of cats and dogs and make a cat and dog detector. And it's all very nice to put in your little project. But if you're trying to do something in a real industrial use case, you're looking at things that there are no photographs of, right? This is like a manufactured part that is halfway through being manufactured, and you're going to have to collect all the data of the failure modes you're looking for or things like that. It might not be even possible to collect data of some things. So finding ways around that problem is going to unlock so much. So things like synthetic data, data augmentation that leans on big generative AI to turn one image into thousands of variations, doing modeling and simulation, foundation models that can live on the edge and run on the edge and reduce data requirements because they inherently have this large sort of general, I don't want to say understanding, but kind of model of the world. So instead of data, you can prompt them. All these are things that are coming and that we're getting better at, and they're going to open up the full sort of diversity of use cases and applications that there are on the edge.
Yeah. Bill, let's go to you next, right? What do you want to see that's the barriers to overcome?
We run into a lot of projects that are still stuck in the R&D stage. And there's been a lot of advancements over the past couple of years with foundation models and frameworks that make it a lot easier to bring an AI application to production. I think that every time we run into one of these scenarios, we find an area that we can help, and we can help accelerate that. So when building in-house, like look to a partner to augment what you're trying to do on your own, whether it's governing the data, it's fine-tuning the model, pairing a use case with a foundation model, identifying the infrastructure, deploying it. Or you can always buy. There's ISVs out there that have figured this out depending on the use case, not for everything, that can help accelerate your time to production. It's just there's so many R&D projects that get stuck for one reason or another, and I'd like to see a lot of these projects get out of R&D into production. over
Yeah,
the
the
next couple
surface
years.
area is huge. It's like boiling the ocean. So
Yeah.
pick your battles. What I'm hearing. Padraig, bring us home. Where's
Well,
it?
I think I'll
where's it
just
going?
key off with this. I think the tooling is actually key to success, because if you think back to on the cloud, think back 10 years, what they've done over the last 10, 15 years, they've made it so easy to basically spin up a server, deploy a database, put an ML, put an AI solution out there. They really built out the tooling, matured it to a point where they made it so easy for us. All you needed was a credit card, and you could do anything you wanted in the cloud. And so I think we need to do the same thing for deploying solutions at the edge. And if we get to a point where if a developer, an app developer, goes to deploy something, and they don't need to know whether it's going to a cloud data center, whether it's going to a retail location, or whether it's going to the top of a wind turbine on the ultimate pass, and if it's just a one button to push and they can go to all three, then I think we will have made a big headway in actually enabling AI
Yeah.
at the edge.
Absolutely. Make it easy, make dealing with the data easy, have the business case. These are all great themes and hopefully great takeaways. Before we close out, I just want to see if anyone in the audience has any questions. Rob has a mic. He can come find you for voice augmentation purposes. Any questions? Okay. All right. Hold on. Here he comes with the mic.
Okay, I can speak loud.
Okay. I think we're recording as well, so this helps for the future.
So you mentioned edge small language models in the future. What are the top one or two that you think are going to be like the game changing ones in
As
the near
in-
future?
Which models are the use cases? Use case. I think what I see is anything where you require specialized knowledge, but it's not easy to get a specialist into that location. You think of healthcare, medical type of scenarios. There's what is it, 9, 10 billion people in the world? And even here in the US, getting access to doctors and specialists is difficult. I think these models will actually, allow you to get that service to people a lot quicker, a lot easier, particularly in remote areas that we don't see today. Also think of like other industries, that are, they're in maybe the industries with aging workforces, maybe industries that require you to operate in maybe inhospitable places. I think those language models are really going to play a big part in getting the knowledge out there to be able to operate those businesses.
Thank you.
Others want to pile on and add to the question
I
here?
think also, use scenarios where you need to process a lot of data really quickly and produce results. For example, self-driving cars, right? Everybody likes to use it as an example. You have to be able to process a ton of data very quickly and make decisions on the spot, right? Like in milliseconds. Those are use scenarios like that will require AI at the edge. There is no other solution for something like this. It's not, hey, I'll work harder. I can do it in a different way. There isn't, right? Those use scenarios are required.
Yeah, I mean, a large language model is massive compared to the small language model. There was a workshop NVIDIA had at last year's GTC where they were walking the audience through installing a small language model on a Jetson device. There was a demo on the floor on IGX where they were inferencing during a surgery off of a camera stream on one model, identifying an anomaly, and then the surgeon was interacting with the small language model, asking it questions, getting advice on what to do next. So the possibilities are great, especially like it's so light, you can run it with another model. And I even think like inventory, if you're using computer vision to look at inventory in a warehouse, quickly asking how many boxes do I have of Acme XYZ on the shelf, and you can interact with it in that way.
Those kind of natural language interfaces
Yeah.
in a lot of different places you can imagine. Dan, anything you wanted to add on this one?
Yeah, I mean, I'd say 5 years ago we were struggling to run 100 kilobytes convolutional network on an edge device. Today we're just casually talking about, in a workshop running a small language model on a device. 5 years time, you're going to have like video games consoles where the game is rendered from a model, not from an engine. Instead of watching like a streaming video, you'll be watching some real-time rendered like story video thing that is generated based on your own preferences. Like we're going to see a completely different world coming out of these generative models that are running on the edge. And it's not just like taking what we're doing now and making it a little bit better. It's going to be things that, no one's ever envisioned before.
Yeah, I want to add something, and you touched on this before, like, are we ready? What's happening? Look, we also need to acknowledge there are other advantages in technology that are maybe on the side, but are crucial for AI at the edge to happen. For example, we are very much involved in, excuse me, 5G deployments. 5G is a crucial technology as being deployed on the sidelines maybe for AI, but not the sideline for others, but, very important technology that opens a lot of use scenarios for AI at the edge. Why? Because the bandwidth is there that doesn't exist in 4G before, the reliability that it generates, the slicing of the network that you can do on 5G that you couldn't do on 4G. So when you start deploying technology like 5G, and people already look at 6G right now, yeah, that's a huge impact on what's happening on the AI at the edge because it opened capabilities it just didn't have before, just couldn't do it before.
Yeah, and that opens up capacity.
Yeah.
Something's going to come along and consume
Yeah,
it.
yeah.
So this is fantastic. Thank you all so much.
Yeah.
This has been really insightful, and I appreciate everyone here in the audience, your time, your questions. Thank you so much, and enjoy the rest of the evening.
You guys.